All right, on to our next section of Chapter 3 in Triola's book, and it's for the most part going to be Chapter 3 of about any book that you're looking at. Sections may vary. Now what we're going to be talking about in this section is measures of relative standing and box plots. So the first video here I'm going to discuss measures of relative standing or measures of position. The positions that we're going to be talking about are z-scores, so we're just going to briefly review the z-score that we already discussed in the last section and see how it is a measure of position. Then we're going to discuss percentiles and quartiles, which are just percentiles themselves. So first of all, a z-score is a measure of position or a measure of relative standing because it is the position a data point holds relative to the mean, and WRT, this WRT right here, that means with respect to the standard deviation. And we know that a z-score is found by taking the data point, the x, subtracting the mean, the x bar or the mu, depending upon what information you have, and dividing it by the standard deviation. So where is it with relationship to the mean, and then with respect, dividing by the ratio of the difference in these two to the standard deviation. And that's what our z-score is, and that is a measure of position. Now a percentile starts first of all with ordered data. So if we take the data and we order it, and we do it low to high, and what we do then is we're going to find out what percentage of data is below a certain value. SAT scores are something that you are probably quite familiar with that involve percentiles. So when you get an SAT score, you don't get a percentage grade. You may think it is, but it isn't. It's a percentile. And what that SAT score tells you is the percentage of people that scored below where you did on the SAT. So if you got a 95%, that doesn't mean that you got a 95% of the questions correct. You could have gotten 2 of the questions correct and got a 95 percentile. The 95th percentile says that out of all the people that took the test, 95 of them scored lower than what you scored on your SATs. So those are percentiles. Now a quartile is a special percentile, and a quartile is percentiles that break the data into quarters. So we have the 25th percentile, the 50th percentile, and the 75th percentile being our quartiles. Now percentiles we mark off with a P with whatever percentile it is, and quartiles we mark off with Q1, Q2, and Q3. Those are the names for the quartiles. Now percentiles could be any percentage from 1 up to 99. We typically don't talk about like the 99.5th percentile. It's possible, but it's just not something we usually talk about. We usually talk about whole numbered percentiles. So those are the measures of position. Now in order to find percentiles and quartiles, we've already discussed z-scores, so I'm done with that. In order to discuss percentiles and quartiles, we need some way of locating where these are. Now there are many different algorithms for finding percentiles and quartiles, but the one that I use to locate my percentiles and my quartiles are what we call, or what Triola calls, the indicator functions. I have something blocking my way here, so I have to move this over for a second so I can turn my page. So the indicator function is going to look like this. So let me write it out. The indicator function, it's going to tell us or indicate to us, right, the position in the data set where we will be able to find a certain percentile. Now another one of the books that I use, the Brace book, uses a much more touchy-feely way, but I still go using the indicator function, and I require all my students to learn the indicator function, and that's how in my classes, when we're finding this information by hand, we find the quartiles in this chapter 3. So the indicator function, we're going to use this L, and I'll use a K here to indicate it. And this is the kth percentile in the data. So kth percentile is what we're trying to locate. And what we'll find here is that this is our k% multiplied by n. And remember, n is equal to your sample size. So if we had 10 data points and we were trying to find the 25th percentile, we'd multiply 25%, which is decimal 0.25, times 10, and that would give us 2.5. Now, sometimes these will be whole numbers, sometimes they'll be decimals or fractions, however you want to look at them. So we need to know what happens when they're a whole number versus what happens when they're a fraction or a decimal. So when they're a whole number, this causes actual problems because what it says is that there's not actually a position in the data that will put this percent underneath. So when it's a whole number, we use that position and the next averaged. And if we get a fraction or a decimal, we round up, or we go up, so it's not really a round, so we go up to the next position. So we're going to use our PerSnatcher data set to show us how we can find the percentiles. So indicator function, again, we're going to find out what percentile do we want, what is the sample size. We're going to multiply those two to give us the indicator. Now this indicator tells us where in the data we will find that particular data point that gives us this position. So where in the data, it is not the actual value yet, it's just the where in the data, is the point that represents the percentile located. Okay, so what we're doing is we're doing a location, right? We're finding the location of this. So let's go ahead and scroll down here and we will take a look at the PerSnatcher data. So with our PerSnatcher data, now the notes here, they're finding the percentile of a given point, which is just the backwards of what we're doing here with location. So I'm changing this example very slightly here, because most of the books anymore are not actually using the finding the percentile of a given point. They're usually just finding different data points that represent the percentiles. So we're actually going to find the different percentiles for the PerSnatcher data. So we're going to find the second percentile, and then we're going to find the 25th percentile, which is also known as the first quartile. And then we're going to find the 50th percentile, which is also known as the second quartile. And it actually has another name that we'll learn when it comes time to learn about measures of center, that is called the median, x tilde. So those are the things that we're going to find. So first off, what I'm going to do is I'm going to find for each of these, I'm going to find my indicator functions of where I will locate these. So I'm going to put these indicator functions in green so you can relate back to what I was doing before. So the indicator function for the second percentile will be 0.02 times the number of data points that I had. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have 0.02 times 10. So we have 2 times 10, which is 20, with 2 decimal points, which puts us at 0.2. So we have 0.2. Now, because that is not a whole number, what we would do is we would round up and we would use the first position. Now notice this is not really truly rounding, it's going up. always. So the first position data point here is this number right here. Now this is a stem and leaf display, which remember this reads 10 times these numbers, so this is 10 plus 1 times these numbers, so 10 plus 6, which is 16. So my P1 or P2, which my second percentile, is going to be 16. So that's how we would do the percentile there. Now let's go ahead and do this again for our P25, which is our first quartile. So my P25 is L25, and that's going to be a quarter of, or 25%, right? A quarter of 10. And so a quarter of 10, that's going to give me a fraction again, right? So we have 5 halves, or 2 and a half. So this gives me 5 halves, and 2 goes into 5 2 times with 1 left over and 2 and a half. So 2.5. Now again, it's not a whole number, so I'm going to round it up. I'm going to go up to the third data point. So my third data point, 1, 2, 3. So my 25th percentile, my first quartile, is 2 times 10, 20, plus 1 times 1, which is 1, 21. So this is 21, and that's my first quartile. Now let's look at the median. So with my median, I have L50, right, the 50th percentile. So that's half of my 10 data points, and so that's going to be 5. Now this one is a whole number, so this is where I use the 5th and the 6th to average. So I'll find the 5th data point, and I'll find the 6th data point, and I'll average them to find my median. So 1, 2, 3, 4, 5, and there's 6. So 5 is 29 plus 6, which is 30, and 29 plus 30 gets averaged, so that will give me 29 and a half. I don't round it off or anything, I just leave it just like that. It's fine, and that'll be my 50th percentile. Now I want to show you a trick with our 75th percentile, and our Q3, and our 25th percentile. We could go through the exact same process for finding P75, our third quartile, as we did for all of the rest of the percentiles that we found here. However, the 25th percentile and the 75th percentile are symmetric, right? If you think about it, 25 is the same distance from the bottom as 75 is from the top. So we can use that fact of symmetry with this information here to go from the top of the data. So this is L25 being 3 from the top. So I'll go to the top of the data, the high end of the data, 50, and I'll count down. So 50, 41, 39. So my P75, my third quartile, is 39, which is kind of nice because then I kind of get 2 for the price of 1 here. Now, one more time, I want to mention that this is just one algorithm for finding the percentiles and quartiles. It is the algorithm that I use in my courses, and this is the one that I expect my students to know, regardless of how the book that I happen to be using in my classes does define their algorithm. Some of the books are very touchy-feely, some of them are a little bit more mathematically rigorous, as the Triola book is, and then we also have the fact that the algorithms can differ totally from either of those extremes, and they can be something like is used in the calculator. The calculator's algorithm is slightly different than this, however it does line up with this algorithm quite often. Every once in a while you'll see just a slight difference. Alright, now I'm going to go ahead and pause, and we're going to come back and see a great big data set, and I want you guys to go ahead and do some of that work on your own. So I'll see you in the next video.